Ladies and gentlemen, boys and girls, good morning. Welcome to the North Carolina Museum of Natural Sciences. And thank you especially for members of the news media who have come here to hear this museum's latest exciting announcement about a new species. And we do so proudly with the Field Museum in Chicago, Illinois. I would like to, before I make my remarks, introduce our scientist here, who is central to the discovery with her colleagues at the Field Museum. I'd like to recognize both Dr. Dan Solomon, who is Dean of the College of Sciences at NC State University. Dan, if you would just rise and be recognized. Thank you. And also to his right is Dr. Phil Carter, immunobiologist and an expert in veterinary medicine, who is the chair of the Museum's Advisory Commission for Governor McCrory. Thank you both. You'll see the connection of NC State as I make my introduction. So in the world of biological sciences, one of the great quests surely is to fully define the biodiversity of the planet today. And that involves knowing what lives where, and how what's living where may be moving in longitude or latitude or altitude, both due to natural and human-forced processes. But the same, and you may recall that last summer we had an amazing discovery, in that case with the Smithsonian Institution, the National Museum of Natural History, on the discovery of a rodent, of a raccoon-like mammal that had somehow evaded human discovery in the cloudy mountaintops of the Andes in South America. And on that exciting day like the one today, Dr. Roland Kays of the museum, who is also joint appointed with NC State University, made the discovery and made the announcement jointly with the Smithsonian. Today, this quest to define biodiversity takes us back to the Cretaceous, the period of geologic time that ends the Mesozoic era and is precisely ended by the moment 64.9 million years ago when an asteroid collided with planet Earth and hit the Yucatan area of Central America, and in so doing annihilated all large animal life, including all the dinosaurs. If we pull back from 64.9 million years ago back into the late Cretaceous, we have a struggle for who's going to be top predator. And you know, at this museum we have one of those top predators, Acrocanthosaurus, that's in display in the part of the museum that opened in 2000. It has its own very special sort of gallery. But today we hear about a discovery which is incredible because of the 60 years since we made a similar discovery about this time in Earth history, about a top predator, a predator that would, not until its species died out, would there be space in the food chain for the tyrannosaurs to become the king of the tyrant lizards, as Tyrannosaurus means. So we're very proud and excited and delighted, and certainly myself as a geologist and as the museum director, Emlyn Costa, a doctorate in geology, that we have here this morning Dr. Lindsay Zano, who is our vertebrate paleontologist, who often in the summers spends weeks upon end in the dry terrain of Utah and has been making a very exciting discovery, which is now defined in the scientific literature as of this week. Dr. Lindsay Zano is not only the head of our vertebrate paleo laboratory on the top floor of this Nature Research Center, but also a joint appointment in biological sciences, a research professor at NC State University, which is why I introduced the two gentlemen to you at the beginning of my remarks. So for the exciting announcement of the details of the what and the why and the how and the significance of it, please welcome Dr. Lindsay Zano to the stage.
Good morning. On behalf of the North Carolina Museum of Natural Sciences and NC State University, I am so excited to announce to you this morning our very newest member of the dinosaur family tree and one of the largest predatory dinosaurs that has ever roamed North America, Siats meekerorum. And there he or she is. So to understand the significance of Siats, we all need to take a trip back in time. And not just geologic time, but back when we were all kids sitting around playing with plastic models of dinosaurs. I'm sure we all remember these days. These plastic models of dinosaurs that we used to play with are some of the most famous dinosaurs that have ever been known. And they come from 2 time periods in Earth's history. About half of them come from a time period known as the late Jurassic, and that's about 150 million years ago. And these are the dinosaurs that we know and love, like Stegosaurus, Brachiosaurus, and even Apatosaurus, which we used to call Brontosaurus. I'm sure we all remember Brontosaurus. The top predator that lived here in the late Jurassic was an animal called Allosaurus. And even though this was the big guy on the block back there, Allosaurus would have weighed in at about 1.5 tons or so in size. Now, the other half of the dinosaurs that we all used to play with come from a very different time period in Earth's history, known as the very, very latest Cretaceous. And that was about 66 million years ago. And these are those fuzzy dinosaurs we know and love, like Triceratops, and of course, the most famous dinosaur that's ever been described, Tyrannosaurus rex. Now, T-Rex was the top dog in the late Cretaceous ecosystems of North America, and was pretty much the only large predator roaming around at that time. Now, for scientists, the big question that's been on our mind for over half a century is this huge gap in the fossil record, over 60 million years, where we had no good fossils of the giant predators that lived and roamed in Western North America during this time. It's kind of just left us with a big gap in our understanding of predatory dinosaur evolution. Well, with that in mind, my very good colleague Pete Makovicki from the Field Museum and I started an expedition to try and discover the dinosaurs that were living in that gap in the North American record. And to do that, we went out searching the hillsides of rocks that we call the mustn't-touch-it member of the Cedar Mountain Formation. Now, these are these drab gray badlands that you can see at the base of this mesa. And these rocks were deposited here in North America at the dawn of the late Cretaceous, the very beginning of the late Cretaceous. Now, the fun part of doing this is when you go to a new area to search for new animals, you're never quite sure, is this going to turn out to be great? Are we going to find great things? Or is this going to turn out to be a big bomb? Well, within just a couple of days of searching these hillsides, I stumbled across the bones of a large animal eroding out of the hillsides of one of these sort of popcorny-like hills. And I looked down at those bones, and they were very thin and very large, and that indicated to us right away that we had something huge, and we had something really significant. And so from that very, very moment, we knew we were onto something big. So just how big is Siats? Well, the number 1 largest animal that's ever lived in North America who was a predator is Tyrannosaurus rex. This was an animal that was named in 1905, so over a century ago, and it weighs in at well over 6 tons. In 1950, scientists found the next biggest animal. It's our very own Terror of the South, who you can go ogle at in the Dinosaur Hall in the main building across the way. And Acrocanthosaurus was, we believe, an adult specimen that weighed well over 5 tons. So what about Siats? Well, Siats we're estimating from the individual that we have, and you can see some of those bones right here, at well over 4 tons in size and over 30 feet long. But there's a catch to this, and that is that the bones that we found of Siats actually come from a juvenile, okay, so an animal that is not fully grown. This means that there's a little bit of room to go here, and we think of a more likely estimate is that Siats would have been about a 5-ton animal when it was fully grown and would have easily vied with Acrocanthosaurus for the number 2 slot in North America. To give you some perspective on how rare these types of discoveries are and why we're so excited about this, it's been a good 63 years since we've discovered an animal that was a predator in North America of this size. So we can now place Siats in our time scale right here at the beginning of the late Cretaceous, right in the middle of that gap at about 98 million years ago. Now the interesting thing here is that when we found this big predator in these rocks in Utah, we thought, well, there's two possibilities here for who Siats would be related to. We thought, well, it must be either a descendant of Allosaurus or an early precursor to T-Rex. Well, it turns out that Siats is actually neither of those things. Siats is actually from a whole new group of dinosaurs that's never been discovered before in North America. It's kind of a mouthful, but we call them neovenatorids. And they've been known from all other continents across the globe, but we had never found one here in the States, so we're very excited about that. The other really exciting thing about Siats is that we actually have the bones and teeth of tiny tyrannosaurs living in the same environments as Siats. And these guys would have been like jackals around a lion kill. They would have been no more than a nuisance to Siats, but it's a very important discovery for us. What it tells us is that in the same ecosystem where we have these colossal neovenatorids like Siats, we have tiny little tyrannosaurs that were about the size of a dog. It wasn't until animals like Siats went extinct in North America that these little tyrannosaurs were able to evolve into the large predators that we know and love and fill those vacant slots in Cretaceous ecosystems. Now, what else are we finding alongside of Siats? We're not just interested in the dinosaurs, even though I'm a dinosaur paleontologist. We want to know about the entire ecosystem, everything that was living alongside this great animal. And to do that, we're studying the tiny fossils. So we don't just want to find those big dinosaurs. We want to find tiny fossils, things that you can hold in your hand, or sometimes fossils you can only see under the microscope. And that helps us fill in the whole ecosystem where Siats lived. We have turtles in this ecosystem and frogs, we have lizards, we have early mammals, and we have a whole variety of crocodiles. We even have some crocodile bite marks on the bones of Siats, so it looks like Siats, after it died, was lunch for one of these crocodiles. Well, we go out to the area where we found Siats every year. We launch expeditions from right here at the North Carolina Museum of Natural Sciences, and you can follow along with us every summer. We have not only found all these small animals in this area, but we have a whole new suite of new dinosaurs that'll be coming out over the next 3 to 5 years. And we're really excited to sort of continually announce all the different new dinosaurs that come from this totally unknown ecosystem. You can follow along with us live. We tweet, we blog from the field at Expedition Live. And also, we do something pretty great and innovative here at the museum. We actually bring you live video feed from the field. So next summer, when we're out digging in the rocks where we found Siats, you can come here to the Daily Planet, and you can see me looking all dirty and smelly, actually talking to you from the field sites where we're actively digging up the bones of these animals. And I have to say, paleontology is a team science. We have dozens of people who not only contributed to the excavation of this animal, but to the incredible preparation and the research. I want to find Lisa Herzog, who's in the audience today, who not only helped us excavate Siats, but also helped us prepare the bones, and Dr. Terry Gates, who's a research associate here, who also did some of the hard labor to get this animal out of the ground. And I have to finally acknowledge the Bureau of Land Management. We work very closely with these folks, Mike Lashin and Rebecca, and these people are charged with protecting our fossil resources out west. If it weren't for these people, we would never be able to collect these animals and bring them to the museum and ultimately bring dinosaurs like Siats to you all. Please come up and take a look at the bones of Siats if you haven't seen them, and I will be around for a bit to take any questions you guys have, and thank you so much for coming this morning.